We will continue working with the Silverlight application and web part that we developed in the previous demo, and we will add some rich UI functionality and further integration with SharePoint. So we have a label, a progress bar, a second label and a stack panel, and currently our Silverlight application, via its initiation parameters, populates the first label with the title of the web part and sets the background colour of the entire grid to a value that gets passed in from the web part. But we will add some more to those values that get passed in. So now, for example, we'll pass in the URL of the current web. So let's declare a variable called web URL and set it equal to spcontext.current.web.url. And remember, this code is running in SharePoint. It's in a standard ASP.NET web part. This is not Silverlight code. We use a string value now, which is the current web's URL, and we will pass that into Silverlight via the initparams parameter. Of course, that will be exceedingly useful for us because it will allow us to instantiate a client context object based on this URL, which will effectively allow us to connect our Silverlight application to the data in the current website. So let's go back to our Silverlight application, and we already have a routine in the application startup for loading the initiation parameters. And just because we have added a new one, we don't need to change that code at all. What we will do first of all is set the value of the progress bar, which is called loader, to 0. Set the value of the status text block to connecting to web, and then we will build a new client context object based on the web URL string that got passed into our Silverlight application. Now we will load the web and call execute query async, and its successful request delegate is called update connection status, and that invokes our own make progress web connection method by calling dispatcher.beginInvoke. And that means we are back on the main UI thread after having called an asynchronous execute query async. So we can do things like update the value of the progress bar, but we can also set the status text to something like connecting to lists, and there we can further call execute query async to get the lists. And so again we have a delegate that does a dispatcher.beginInvoke to our make progress lists connection method. We again increase the value of the progress bar and set the status text to something more appropriate. And there we can start working with the document library and its root folders and its files, and again load them and call execute query async one more time. When that execute query async completes, we will call getListData, which again uses dispatcher.beginInvoke to call load files. And in load files, we execute query async for each file in the files collection. And what we will do is add the file to the UI. Again, because the query is asynchronous in nature, we call dispatcher.beginInvoke, and then we have our function for adding the files to the UI. So let's recap that, as there are quite a few of these. We first of all switch to the main UI thread after the first execute query async. In that procedure we call another execute query async, and then in its delegate we switch back to the main thread. So we continually do this. We're continually switching between the main UI thread and a background thread, and then returning context to the main UI thread again. So we can build that now. And the reason we do all that is that we are not allowed to execute queries synchronously on the main UI thread in Silverlight, as that's a potential blocking issue. So we'll now deploy our web part, and we can visit our page that has our Silverlight control on, and you can see that the progress bar updates and the status text gets displayed appropriately in real time. So what we have really done is updated the UI in real time, so the progress bar is actually very accurate, although it loaded quickly because the operations are fairly quick. And it does provide a rich UI and some rich feedback to the user. So this is all done because we switched to background threads to call execute query async, and then we switched back to the main UI thread with those dispatcher.beginInvoke calls to make sure that we can update the UI when those calls have been successfully completed. Now in the next demo for this module, we will develop this control further to build an entire media wall with simultaneously playing videos. The point of this demo was to show you the architecture of calling execute query async and dispatching back to the main UI thread when we need to update the UI.